Act 1. Cold Open. Imagine the night sky over Earth in the autumn of 1959. The moon hangs in darkness, half lit by the distant sun. And then, a flash. A brilliant, unmistakable flash of light blooms across the lunar surface, visible to the naked eye from Earth. A mushroom cloud rises in the vacuum, dust and regolith thrown skyward in a silent, terrible bloom. For a moment, the moon itself becomes a weapon. For a moment, America wins the space race in the most brutal way imaginable. Except it never happened, but it almost did. Act 2. Context. The year is 1957. The Soviet Union launches Sputnik, and the Western world reels. A beeping metal sphere orbits overhead, and suddenly the Americans are not the technological masters they believed themselves to be. The implications are staggering. If the Soviets can launch satellites, they can launch missiles. If they can reach orbit, they can reach American cities. Months pass. The Soviets launch Sputnik 2 with a dog aboard, a living creature returned alive. Then Luna 1 misses the moon. Then Luna 2 crashes into it, becoming the first human-made object to reach another world. The Soviets have claimed the moon. By late 1958, the psychological damage is done. The U.S. military is in crisis. Congress is demanding answers. The public is afraid, watching the skies with a new kind of dread. And in the corridors of the Pentagon, among the war rooms and classified briefings, a desperate idea takes shape. It is audacious. It is technically possible. It is, in the eyes of those who propose it, necessary. If we cannot reach the moon first with a man, the thinking goes, we can reach it first with a bomb. A nuclear detonation visible from Earth. A flash of American power written across the lunar surface. A message to the world, and to the Soviets, that America still commands the future. Act 3. Rising Action. In the summer of 1958, the U.S. Air Force Special Weapons Center at Kirtland Air Force Base in New Mexico receives a classified directive. They are to study the feasibility of detonating a nuclear weapon on the lunar surface. The goal is not military conquest. It is not even science. It is pure propaganda, a visible, undeniable demonstration of American nuclear power and technological reach. The project receives an innocuous name, a study of lunar research flights, Project A-119. The team assembles quietly, 10 people, engineers, physicists, mathematicians, and among them a young graduate student named Carl Sagan. Sagan is not yet the famous astronomer and science communicator. He is a brilliant, ambitious researcher at the University of Chicago, and he is hired to solve a specific problem. What happens when a nuclear explosion occurs in the vacuum of the moon? How does dust behave without an atmosphere? How far does the cloud expand? How bright is the flash when seen from Earth? For Sagan, the work is both thrilling and strange. He is 27 years old, still building his reputation, and here he is, contributing classified research to a project so secret that even its name obscures its purpose. The calculations are elegant but unsettling. In the absence of air resistance, the dust cloud would expand in a perfect sphere, unimpeded by the forces that shape explosions on Earth. The brightness of the detonation, reflected off the lunar surface and visible from Earth, would be unmistakable, a flash in the night sky. Proof.
The warhead is selected with deliberation, a W-25 nuclear device, roughly 1.7 kilotons in yield, small enough to fit aboard an existing ICBM, large enough to be unmistakable. The target is chosen with precision, the terminator line, the boundary between the lit and dark side of the moon. At that line, the flash would be illuminated by the distant sun, creating a visible dust cloud that could be seen from Earth with the naked eye. The contrast would be stark. The message would be clear. The timing is calculated. The trajectory is plotted. The logistics are refined. By late 1958, the plan is not theoretical. It is operational. The machinery of Cold War urgency has transformed a concept into a schedule. Somewhere in the Pentagon, in the offices of the Air Force Command, the question is no longer whether this can be done. It is when. Act 4. Turning point. But as the project moves forward, objections begin to surface, and they come from unexpected places. Sagan's own research on dust cloud expansion reveals a problem that cuts to the heart of the mission's contradiction. The explosion would not simply create a visible flash across the lunar night. It would irradiate the lunar regolith, contaminating the surface with radioactive particles that would persist for decades. Any future scientific mission to the moon would land on a contaminated world. The pristine geological record, billions of years of lunar history locked in undisturbed rock and soil, would be destroyed. The very thing that made the moon scientifically valuable, the reason scientists had dreamed of reaching it, would be compromised forever. A propaganda victory on the moon would come at the cost of the moon itself. There are other concerns, more immediate and earthbound. A launch failure could drop a nuclear weapon on American soil. The rockets were still new, still unpredictable. And then there is the matter of public knowledge. The public, when they learn the truth, and they would learn, might not celebrate. They might recoil. A nuclear explosion on the moon might not look like triumph to the world. It might look like madness. It might look like the military-industrial complex run amok, willing to weaponize the heavens for a propaganda stunt. And then there is the matter of the Soviets. Intelligence reports suggest they are considering something similar. Project E-4, the Soviets call it. A parallel plan to detonate a nuclear device on the moon. If both superpowers were racing to nuke the moon, the world would know. The arms race would have reached the heavens. The Cold War would have become cosmic. The logic of deterrence, which had kept nuclear weapons pointed at cities on Earth, would extend to the stars themselves. Act 5. Consequences. In early 1959, Project A-119 is quietly cancelled. No announcement, no press release. The files are sealed. The team disperses. Sagan returns to his academic work, his contributions to the project locked away in classified archives. Rifle continues his career in aerospace research, the weight of what might have been settling into silence. The plan is buried so thoroughly that for 40 years, almost no one knows it ever existed. The moon remains untouched. The mushroom cloud exists only in calculations and contingency plans.
Then, in 1999, Leonard Rifle, now in his 70s, decides to talk. He gives an interview to Nature magazine. He describes the project in meticulous detail. The warhead specifications, the targeting coordinates at the lunar terminator line, the team assembled in the New Mexico desert, the moment when the decision came to step back from the edge. The world learns that America once seriously considered detonating a nuclear weapon on the moon, not for science, but for propaganda. The revelation spreads through the scientific community like a shockwave, rippling into the mainstream press. The Observer publishes a major feature. Historians begin to dig through newly declassified documents, and in the process, Carl Sagan's involvement emerges, not from Sagan himself, who died in 1996, but from his biographer, Key Davidson, who uncovers Sagan's classified contributions while researching his life, finding the dust cloud calculations, the modeling work that a young graduate student had performed in service of a plan he may not have fully understood. The declassified documents tell the story in cold, technical language. Sagan's calculations, the warhead, the objections, the cancellation. What emerges is not a story of American triumph or Soviet threat. It is a story of Cold War desperation, of a moment when the military-industrial complex came perilously close to turning the moon into a nuclear test site, and of how, at the last moment, reason prevailed. Act 6. Reflection. Project A-119 was never executed. The moon remains untouched by human nuclear weapons. But the plan itself is a window into a specific moment in history, a moment when the space race was not about exploration or science, but about dominance and fear. It is a reminder that the Cold War was not just a political or military conflict. It was a psychological war, fought in the realm of symbols and spectacle, and it is a testament to the power of dissent. Sagan's research, Rifle's objections, the concerns about contamination and public backlash, these voices prevented a catastrophe. They preserved the moon as a place of science, not a battlefield. If forgotten footnotes of the Cold War are your kind of history, the next one is already waiting.